Good day, everyone. So today I will discuss about structural formulas. Actually, this is just a continuation of what we discussed on our previous lesson, which is the empirical and molecular formulas. Okay, so organic compounds are molecules that have carbon and hydrogen, right? But they can also have other atoms like oxygen, nitrogen, sulfur, and even phosphorus. We can represent these organic compounds by its name, okay, or molecular formula, or structural formula. But how do we represent structural formulas? Because on our previous lesson, we discussed that we can acquire the molecular formula from the given percentage by mass of different atoms. Okay, now there are three ways on how we can represent the structural formulas. Let's start with something simple. For example, a molecule like propane, which is C3H8, we have many ways to represent it. One is the Lewis structure. So we discussed this in our lesson on chemical bonding. So you have 3 carbon atoms and 8 hydrogen atoms with 10 single bonds. Another way is the condensed structural formula, which gives us different groups in that molecule. So we have CH3 bonded to CH2 and then another CH3. So a little structure gives us a little more information because we actually see exactly how the atoms are bonded to each other. These are all very helpful, except that it takes a really long time to draw it, and we are only looking at a 3 carbon chain, right? Now, imagine if you have to draw the same thing for a molecule like octane, which is 8 carbons long, or decane, which is 10 carbons long. Now imagine you're doing the mechanism and you have to draw a version of the molecule once and again and again and again. Not only is it going to take so much time, can you imagine if you're taking an exam? So how messy your paper is going to be, right? So you need a simpler and easier way, and that's why we have the line angle structural formula. It is also known as the skeletal structure. So we can quickly and easily represent these molecules and still know exactly what's going on. So the trick with skeletal formula or skeletal structure is that we want to make this as simple as possible, and that means we're gonna assume rather than show a lot of what is going on. All right. Okay. So you don't show any hydrogen atoms that are on carbon. You only show the bonds between the atoms. And again, unless it's carbon to hydrogen. So how does this work? So if we have the molecule like propane, we're not going to show the carbon atoms, but we're going to show the bonds between carbon atoms. So that means we have 1, 2, and 3. 3 carbon atoms and 2 bonds between them. All right? So 1, 2, 3 carbon atoms, and then we have 2 bonds between them. So that means so we're not gonna show any hydrogens. We're gonna simply assume that they are there and it looks like this. All right. Okay, so you have three carbon atoms. Okay, and then you have those hydrogens. So this line represents the bond between two carbon atoms unless something else is shown. And so we have, once again, one, two, and then three carbon atoms. So we draw a line and another line. Okay? But the problem is that a lot of students count it when they draw a line rather than the first atom you write. So they draw a line and call that carbon 1 and then 2. But this is incorrect. All right? That is incorrect. When you're drawing it, remember you have fewer bonds than you have atoms. So three carbons have two bonds between them, and the trick to recognize is that every corner, every angle, every bend represents another hidden carbon atom. Okay? So with that same structure, even though we only have two lines, we have a total of one, two, and three carbon atoms. So again, we have one, two, three. That's a three carbon chain. I keep on repeating this because most of the students made a wrong assumption on this. All right. So now, what about those hydrogen atoms? Where are they? Honestly, we don't care. Okay, we don't care. They're there, okay, but we don't need to show them. If you're trying to figure out how many hydrogen atoms you have for the molecular formula, use this trick. Knowing that a carbon atom has a total of four bonds, we take the number four and then we subtract the number of visible bonds. So visible bonds means it's not connected to hydrogen. And whatever is missing is a hidden hydrogen atom. All right. So if we look at carbon number one, so this is carbon number one, we see one bond to carbon number two. All right. So 4 minus 1 is 3. So that right there would be our three hydrogen atoms. All right. And then carbon 2, okay, carbon number 2 has a one bond to carbon number 1 and another one bond to carbon number 3. So that's two bonds. So 4 minus 2 is 2. And so we have two invisible hydrogen atoms. And again, for carbon 3, it has three more hydrogen atoms. I'm explaining this to you so you understand that it's there. But I want you to forget the hydrogens and simply focus on the skeleton at hand. All right? So that is for your line angle formula. So our next example is butene, C4H8. So the Lewis structure, we have four carbon atoms, all right? And then we have eight hydrogen atoms. Okay. And they are connected with bonds. So are we good? No, because these two carbon atoms, they only have six electrons. So one, two, three, four, five, and then six. And then the other one, two, three, four, five, and then six. So therefore, we need to add another bond to follow the octet rule. So this is the double bond. Okay, and if we will count the number of electrons around this carbon, it is now 1, 2, 3, 4, 5, 6, 7, 8. So it is now complete. Same goes with the other carbon. Okay, and this is the condensed formula. Okay, so if there's a double bond or a triple bond in a formula, it must be visible in condensed formula. Okay, so please take note of that. Double bond and triple bond are always visible in a condensed formula. All right. Now, for line angle or skeletal structure, in this case, we have a total of four. Okay, so we draw a zigzag of four carbons. So one, two, three, and then four. So if you're not confident, just add the dots and count them or number accordingly. And then to show that double bond, well, we simply show a double bond by drawing a second line or that second bond between carbons 2 and 3. As for the hydrogens, all right, they are there. Okay, so we have four carbon atoms, and then we have those hydrogens, right? Okay, so they are there, but you don't have to show it. Okay, so there you go. So they are invisible. All right, so let's move on to the next slide. Our next example is C3H8O, or the chemical name is propranolol. Okay, this is actually a medicine used to treat high blood pressure, or some people who have stage fright take this. So they won't be nervous or their voice would not be shaking. Anyhow, we have the Lewis structure. Okay, so we have three carbon atoms and then one oxygen atom. And then we have eight hydrogen atoms connected with bonds. All right, but it's not yet over because we have to show the two lone pairs of oxygen. Okay, so there you go. So remember our lecture in chemical bonding? It is very important that you have to place those unpaired electrons to show that the structure followed the octet rule. Okay, now for the condensed formula, okay, so you have four groups. So you have CH3, CH2, O, CH3. And this time, you don't have to put dots around oxygen since this is a condensed formula. All right? So for skeletal structure or line angle formula, all right, so this is it. So you don't show any hydrogen atoms that are on carbon. You only show the bonds between the atoms again. However, the only atoms you show are the non-carbon and hydrogen atoms, like oxygen, nitrogen, sulfur, phosphorus, and so on. So in this case, we have to add or we have to show the oxygen in this skeletal structure. And of course, it's four dots. All right. So in line angle or skeletal structure formula, you have to show the lone pairs. Okay. Or the four dots. So, well, again, the hydrogens are there. Okay. But they are invisible. All right. Okay, so what is this resonance structures? So resonance structures are a way of understanding the positioning of electrons. So this is actually a vital topic for chemistry, as understanding where electrons are located within the molecule is the key to understanding the molecule's chemical behavior. All right. So you can't really say anything about chemical reactivity or chemical properties without knowing what parts of the molecules are electron rich and which are electron poor. So this is an example of resonance structures, right? Which is indicated by a double-headed arrow. Now, in this example, we have two completely equivalent Lewis structures of sulfur dioxide, right? SO2, this is sulfur dioxide. So they are completely equivalent Lewis structures of sulfur dioxide. Well, experiment shows that both bonds, right, in sulfur dioxide are equivalent. Okay, they are equivalent. So the actual sulfur dioxide molecule with its bond distances is actually, all right, it is actually a blend of the two Lewis structure. Okay, so they are a blend of two Lewis structure. That's why each of these structures is called the resonance structure. Okay, so these are the resonance structures. Okay, so benzene. So this is the resonance structures of benzene. Okay, so what do you notice with these two structures? Okay, so these are the resonance structures of benzene, but often this resonance is represented by this. Okay, where okay, here where the circle shows the blending, okay, the blending of the resonance structures. So there are also other compounds containing this ring structure, and they are called aromatic compounds, which we will discuss after the midterms. All right. So this is actually the combination of these two resonance structures. All right. All right, maybe you can try this one. So this is a challenge problem. So you have to give the Lewis structure, condensed formula, line angle, skeletal formula, and resonance structure of C3H6O. So the first two students who would send me the correct answer will get a plus 2 points on their midterm percentage grade. And then the next three students, or rather, yeah, and then you would also be exempted on the long quiz. And then the next three students would get plus 10 points in the on our last quiz or quiz 5, and they have the possibility of gaining additional points in their midterm percentage grade. All right. So I need first five students to get those additional points, or two students to become exempted on quiz number 5. All right. So that's all for today. Thank you and God bless.